All right, so this is graphing part 2, and we're going to be looking at multiple choice where you don't have a calculator. So getting through these multiple choice questions they are going to be a little difficult, but you're going to have to rely on the attributes that we discussed in the previous video. So if you didn't watch that video, it is a little lengthy, but I would suggest you go watch that because I'm going to be using information from that video and also the previous videos. So when working with multiple choice questions involving polar functions, it is advantageous to evaluate the function at several values of theta. Utilizing the multiple choice options can be helpful. Now, I agree with this, but there are other ways to approach this that can eliminate potential wrong answers. So my first suggestion, instead of just throwing in thetas, is use the symmetry. Using the symmetry will usually knock out about 2 choices, okay? So if I look at this polar curve, I should be able to either fold it horizontally or vertically. If I try to fold it horizontally, so I fold the top over the bottom, I see that this leaf here, it would end up landing here, and there's no part of the curve there, so it wouldn't overlap itself. And then same thing on this side, I also do not have a leaf here, and then there's no leaf up here to fold over the petal that's here, or I'll call them petals to stay consistent, okay? So it does not have horizontal symmetry, so let's try vertically. Now, this petal here, if I were to fold this left to right, it would cover that petal. And then if I were to take this half of the petal and fold it, it would cover this petal. So this polar curve does have vertical symmetry, which means it is a sine function. So now that I know that this has vertical symmetry and it has to be sine, I can eliminate C and D. And then this raises your chances of getting the correct answer. Okay, so the next thing we do from here is you do want to test some points. All right, the first thing that we need to figure out is where are we starting. All right, so my suggestion for testing points is start at theta equals 0. So we have option A and we have option B. So let's test it in both. So if I plug in 0, 3 sine of 3 times 0, we get 3 sine of 0. Sine of 0, 0 degrees or 0 radians, that is going to be 0. So we end up with 0. That means when theta is 0, that means r is also 0. So A is telling us that we're starting at the pole, okay? Which for petals, you're usually going to start on the pole, or you're going to start on the polar axis on the positive side or the negative side. So for petals, you're mostly going to start somewhere along the pink line here, okay? So that tracks. So let's try B. So if we do negative 3 sine of 3 times 0, I get sine of 3 times 0, which is sine of 0. So we get 0 again with a radius of 0. So plugging in theta equals 0 doesn't help us between A and B, but at least now we know where we are starting. Now this polar curve, let's see where we're going to go next. So we noticed yesterday when I drew these petals is that they were going in this direction, right? Counterclockwise, right? They were all starting at the pole and then going counterclockwise when they were sine. With cosine, we were starting on the polar axis, but they were still going counterclockwise, okay? So this consistency is going to take us through these multiple choice problems. So if I'm starting at the pole, I'm going to go counterclockwise. So I'm going to go this direction. And with your petals, you're going to pass through the pole smoothly, all right? There's no sharp turns like a cardioid, all right? So we're going to pass through into the bottom here. And then again, we will pass through smoothly into the second quadrant. And then it brings us back to where we started for the first petal, okay? So let's try something in quadrant 1. Now keep in mind, this first spoke is pi over 12, and then the second spoke is pi over 6, okay? And then pi over 4, pi over 3, and then we have 5 pi over 12 up here. So in our polar coordinates, the first spoke is no longer pi over 6 anymore. It's going to be pi over 12. They are all spread out by 15 degrees. Okay. Okay. So let's try pi over 6. When you're testing angles, like look for an integer. Like I wouldn't want to try pi over 4 because it's like it's just above 2, but I don't have a calculator, so I don't know what that decimal is going to be. So look for your integer values here. So if we do theta is equal to pi over 6, let's do a first. So a is 3 sine of 3 times pi over 6. We end up with 3 sine of pi over 2. Pi over 2 is going to be up here. And if we evaluate with sine, that's going to be 1. So we have 3 times 1, which is 3. So we have a polar coordinate of 3 pi over 6. So test it. If I start at the pole, I'm going to extend with a radius of 3. And then I want to open up to pi over 6. So I'm going to go counterclockwise because it's positive to pi over 6. And we are good. So A works, but that doesn't mean it's the correct answer, because if B also works, we need to test another point. So let's try B for theta equals pi over 6. So I have, whoops, that should be negative. Negative 3 sine of 3 times pi over 6. We get pi over 2 again. Sine of pi over 2 is 1. So I have negative 3 times 1, which equals negative 3. So now we have a polar coordinate of negative 3 pi over 6. Now when I graph this, I start at the pole, but because the radius is negative, I now travel to the left, out to 3. So this says 3. That's how I know how to go out to 3, okay? Once I get here, I open up pi over 6, but I still go counterclockwise. It's a positive angle, so I open counterclockwise. So I'm going to go to the second spoke. And according to B, we should have a coordinate here that's on the curve, and we don't, okay? So that means A is the correct answer. Now, while we're looking at this, I want to talk about the petals. This petal, if you notice, with A, we had a positive radius. This first petal has a positive radius traveling counterclockwise. Now, when you pass the pole, that's going to negate the radius. So now we have a negative radius down here. Okay, this petal has negative radius. And then when we pass the pole again, we end up with positive radius. And then we come back to the start. Do I believe that? Positive. So if I plug in positive, negative, positive. This is from 0 to 2 pi. Oh, wow, these are both negative, actually. Because if we think of our unit circle, as I go around 0 to 2 pi, this one's in quadrant 1, so it aligns with quadrant 1. But the next part should be positive, but it's not. It's below. And then this one should be over here. So it looks like both of these petals might be negative. A way to find out is to plug in angles, but we didn't get that far into this. We didn't need to. We were able to stay in quadrant 1 and find the choice. So maybe we'll be able to play around with this a little bit more and see what happens. All right, let's take a look at this one. Now we are dealing with an inner loop, so we don't have petals. So petals are going to deal with coefficients with the thetas. Your inner loops and your cardioids will not, okay? It's from this video, so if you look, the cardioids and the inner loops, and the beans, the thetas are isolated. For petals, they are not, okay? All right, so we're dealing with a inner loop. So we have to identify the polar function, or the expression for this. First thing, symmetry. Let's check out the symmetry. Does it have horizontal or vertical symmetry? Well, if you fold it vertically, we see that symmetry, which means we are dealing with sine theta. So let's eliminate C and D because they both have cosine. And now we go to testing points again. So let's start with theta equals 0. So we'll do A, and then we'll have a separate part for B. So we have 2 plus 4 sine of 0. Well, sine of 0 is going to be 0 again. And then we have 4 times 0, which is 0. So we have 2 plus 0, so we get 2. So when our theta is equal to 0, we have a radius of 2. So I will trace that from the pole. So I go out radius of 2. My theta is 0, so I'm just on the polar axis. For B, let's see if it's the same, most likely. It will be, because now we're subtracting 0 instead of adding it. So we get 2 again. So we have a polar coordinate of 2, 0. So theta equals 0 is not helping. All right, so now we need to try another point. Well, if I look at this, again, I want to choose something that's going to help me. So from here, if I look at this, I'm going to curve around. I want to see what's happening as we curve around. So as I curve around, I can see that maybe at pi over 2 something is happening. I'm either at the pole or I could have a negative radius, but I'm checking along this vertical axis, where is this curve aligning? So at pi over 2, we should either be at the pole or we should be in the inner loop by then. So let's see what happens. For inner loop curves, your negative radius is going to occur here. So the inner loop will be the negative radius because we're passing the pole. Anything that's not in the loop will have a positive radius. All right, so let's see what happens. Let's try pi over 2. So when theta is equal to pi over 2, we will have 2 plus 4 sine of pi over 2. Sine of pi over 2 is going to be positive 1. So we end up with 2 plus 4 times 1, which equals 6. So this part A is telling me that at pi over 2, we should be at 6, which the max radius would be 6, but that only occurs here. So let's see what B says. For B, we have 2 minus 4 sine of pi over 2. Again, sine of pi over 2 is positive 1. So we have 2 minus 4 times 1, which is equal to negative 2. So for A, we have a polar coordinate of 6 pi over 2. For B, we have a polar coordinate of negative 2 pi over 2. So let's think about this. This polar curve is opening counterclockwise. So I start here, and then I should be opening up this direction. So this is from 0 to 2 pi. That's what the domain restriction told us, right? And we are opening counterclockwise to go all the way back. So by the time I reach here, I'm back at theta is equal to 2 pi. Now, if we take a look at this, for pi over 2, this is really far in the curve to just be pi over 2, right? Pi over 2 should be a fourth of the way through the curve. And if I look at this, I have two choices. I have a radius of positive 6, which is here, or I have an option of a radius of negative 2, which is here, okay? So I have positive radius, and then I have negative radius as I pass through the pole. And because this is, if I were to try and plot this, I would go, what was it? Negative 2 pi over 2. So I open up negative 2 to here, and then I open up pi over 2, which is I still open counterclockwise. So I go this direction, and I do end up on the curve, okay? And then if I try B, I'll underline it with pink. I have negative 2, wait a minute. Sorry, that was B. I just plotted B. If I try A, which is 6 pi over 2, I go out to 6, and then I open up to pi over 2. There's nothing up there, right? Therefore, the correct answer is going to be B. All right, let's try this next one. So example 15, a portion of the graph of the polar function where f of theta equals negative 3 sine theta is shown in the polar coordinate system. For A is less than or equal to theta, which is less than or equal to b. If 0 is less than or equal to a, which is less than b, which is less than 2 pi, which of the following could be the values for a and b? So basically this is asking, okay, what angle are we starting at and what angle are we ending at, okay? So if we look at this, you could try and imagine what does the rest of this look like. I mean, it could be a leaf like that. It could be a inner loop. It could be a bean. It could be a multitude of things, but you don't want to assume, okay? So we're not going to, but we can because we have the actual function, okay? So a petal, if we were to have petals, we would have a coefficient in there. Now, technically the coefficient is 1, and if it's an odd coefficient, that's how many petals we have. So technically, this is going to look something like this. You can think of it as 1 petal. Or you can also think of it as, where is it? Let me see. You can think of it as, oh, it is just 1 petal. I was going to call it a bean, but a bean has a coefficient. Okay, so we can consider this as having 1 petal. Okay, so now the next question is, where do we start? We want to figure out what is this theta? What is this angle here? And we also want to figure out what is this angle here. Now we know the orientation, it's going to open up counterclockwise. So we are going to start on the maximum radius of 3, so r is equal to 3 here, and then at the pole, r is equal to 0. So that is somewhere that we can start, all right? So the first thing you want to look at is orientation. And then the second thing you want to do is test angles, okay? Always start with r equals 0. And then the second one is you can start with r equals 3 or the max rate or the max radius. If all else fails, you'll also have to do the negative max radius or the minimum radius, I should say. So if we can't figure out what this is with 0 and 3, I'll also have to test r equals -3, okay? Let's do when r is equal to 0. So we'll have 0 is equal to -3 sine theta. Divided by -3, we have 0 is equal to sine theta. Now this is strictly from 0 to 2 pi, all right? So we could do infinite solutions, but we know we're going from 0 to 2 pi. If I plot 0 is equal to sine theta, I have 0 and pi. So theta is equal to 0 or pi. Now this is for at the pole, all right? So these are potential angles at the pole or the center of the polar coordinate grid. But I should already be asking questions, okay? Like, first off, if this is the end of my interval, how do I end at 0 if my domain restriction is from 0 to 2 pi, all right? That means our first angle would have to be negative, which can't happen because that's not part of our domain restriction. So if I'm looking at B versus A, my B cannot be 0, right? It has to be pi. It has to be pi because I cannot have a negative angle. So if I look at my choices below, my B has to be pi. Which choices offer that? Is it A? Nope. So we can cross that out. Is it B? Maybe. Is it C? Maybe. And then is it D? No. So if we're ending at the pole, that means it has to be a positive angle that is less than B based on that domain restriction. Okay, so now let's figure out what angle can we find that has a maximum radius of 3 that is less than pi. So we'll set 3 equal to -3 sine theta. Divide both sides by -3, we get -1. All right, and then on the unit circle, we have one angle. It is going to be theta is equal to 3 pi over 2. That's unfortunate because we need an angle that is less than pi, but 3 pi over 2 is not less than pi. So this will not work, okay? So this is a case where we are going to have to try r equals -3, which is our minimum, okay? Because we can reach the edge, we can reach this radius whether it's positive 3 or negative 3. So now let's plug in negative 3. Divide negative 3 by negative 3, we get 1 is equal to sine theta. On the unit circle, that is going to be pi over 2. So theta is equal to pi over 2. So now we do have a choice for this. If we look at B, we have an A value that is pi over 2, and we still have our B value that's pi. That means the answer is B. So again, look at orientation, see where you're starting, see where you're ending. If you know you're ending at the pole, that means your other angle has to be less than what you have found that's at the pole. All right, let's try this last one. The figure shows the graph of the polar function r equals f of theta when f theta is 6 cosine 3 theta. So we have 3 petals that have horizontal symmetry because it is cosine in the polar coordinate system from 0 to 2 pi. There are 4 points labeled A, B, C, and D. If the domain of f is restricted to pi over 3 to 2 pi over 3, the portion of the given graph that remains consists of 2 pieces. One of those pieces is the portion of the graph in quadrant 3 from C to D. So they are talking about this portion. C to D. Which of the following describes the other remaining piece? Okay, so there's a lot going on in this example. First off, understanding orientation is going to make this so much easier to solve. If it's cosine, I'm going to be starting on the polar axis, and I'm traveling counterclockwise. It goes through the poles smoothly. Okay, so I'm coming around this way, goes through the poles smoothly again, back up here. And then as I finish around here, it goes through the poles smoothly to finish back where we started. Okay, so approaching this one, it's saying that the first portion is from C to D. Okay, C to D. So that means at C, this has to be theta is equal to pi over 3. Okay, so the first step is look at your orientation. Second step is consider theta is at the pole. Okay, so I'm going to start with theta equals 0 again. So if I know that this is theta is equal to pi over 3, I need an angle at the pole that will be greater than pi over 3 because I know that the orientation is going counterclockwise. All right, so set 0 equal to the function. Divide both sides by 6. We get 0 is equal to cosine 3 theta. And on the unit circle, cosine is equal to 0 when we have pi over 2 and 3 pi over 2. So I can do 3 theta is equal to pi over 2 plus pi k. This is from trig solving unit because they are spaced out by pi. Now we multiply both sides by 1/3. So I get theta is equal to pi over 6 plus pi over 3k. So we are passing the pole first at pi over 6. Okay, so if I want to find the other times that I pass the pole from 0 to 2 pi, I can rewrite this so we have a common denominator. So we have pi over 6 plus 2 pi over 6k. So these are the times that we are passing through the pole. So the first one is going to be pi over 6, which is less than pi over 3, so it won't be that one. Let's try the next one. Let's do pi over 6 plus 2 pi over 6. That gives me 3 pi over 6, which is pi over 2. Now, pi over 2 is past pi over 3, all right? And we need to find the angle that is just after pi over 3. So we know pi over 6 is before pi over 3, and then pi over 2 is just after pi over 3. So we can use theta is equal to pi over 2. So that means from here to here, my theta is equal to pi over 2. Now, pi over 2, our angle, it has to be between pi over 3 and 2 pi over 3. And if I think of the unit circle, I have pi over 3 here, 2 pi over 3 here, which means pi over 2 is right in the middle. So that means theta is equal to pi over 2. So that means the start of the next section will be at D. And if we follow the orientation, it will go to A. So the next portion of the graph will be from D to A, which is part C. Now, knowing that we were starting at C and going to D, you're able to eliminate B, right? We can't go, like, we're starting at D, okay? Now, if I were to erase all of this, like the very first thing that I did was follow the orientation of the graph. I was like, okay, I'm starting here on the polar axis. My orientation is this way, passing through. They said that the first section is from C to D. So I go C to D. And if I understand how to sketch this, I'm passing through the pole smooth. I already see that my next section will be D to A. Without any work, you can figure out what that next section is just by following the orientation and understanding the curves. Doing that, you would not have to do all of this, right? So that's why I emphasize, if you understand orientation and how it passes through the pole, depending on what type of polar curve you're looking at, you can save so much time, okay? All right, hope this video helps.